Okay, so the second half of the review for finals, number 9. This is a difference quotient problem where the difference quotient is f of x plus h minus f of x all over h. So we are going to construct and simplify the difference quotient for this function. F of x equals 3x squared plus 3x. So remember, the very first thing you're going to want to do is rewrite this with x plus h in place of these x's. So if I do that, I'll have 3. In place of the x, I'll put x plus h squared plus 3. In place of x, I'll put x plus h. Now, after that, that takes care of this first part. Then you're going to subtract in parentheses the exact function as it is, which is 3x squared plus 3x. We'll worry about the denominator later. So let's simplify what we have here. The first thing you're going to need to find is what x plus h squared is. X plus h squared. So I'm going to FOIL that. I'll do that up here. So when I FOIL this, x times x gives me x squared. My outer x times h, xh. My inner is another xh. And then my last h times h is h squared. Those two terms in the middle, now I can put these two terms together. So I'll have x squared plus, putting these together to 2xh plus h squared. So that's what I'm going to put in place of this x plus h in parentheses squared. So I'll bring down the 3. Open parentheses. What this x plus h squared was, which is x squared plus 2xh plus h squared. So after I do that, then I'm going to distribute the 3 to all of this. So 3 times x squared gives me 3x squared plus 3 times 2 gives me 6xh plus 3 times h squared gives me 3h squared. So that took care of this first part. Okay, now I'm going to distribute the 3 to this parentheses. So I have 3 times x, so that gives me plus 3x plus 3h. And then I'll distribute the negative to the last parenthesis. So let's see, this gives me negative 3x squared minus 3x. Now remember, when you distribute this negative to that last parenthesis, you're creating terms that are going to cancel terms up front. So this negative 3x will cancel out that positive one, and the negative 3x squared will cancel out that positive one. So let's see what we have left. We've got this 6xh plus 3h squared plus 3h. What do all 3 of these terms have in common that we always pull out at the end? That h. So you're going to take an h out of all 3 terms, which will leave you with 6x plus 3h plus 3. And remember, your denominator of the difference quotient is an h, which those h's cancel. So you're just left with what's in those parentheses. Number 10. This is graphing a radical function, a square root. F of x x equals -3 square root of x. Okay, so again, this is going to be multiple choice. So let's put this in our y equals and get some points. Okay, you may be able to just tell from when you graph it. So y equals -3 second square root, right? Your square root button is this one right here. Since it's blue, you need to push second. Put your x in there and then graph it. So it is that square root shape, and it's flipped upside down, right? Since it's negative. So let's get a couple of points. Go to second table, and let's get some good points. I'm going to do the point 0, 0. Let's see, it looks like the next point is 1, -3, 4, -6. I'm doing good whole number points. So let's see what these 3 points will give me. 0, 0. Right at the origin. 1, -3. So to the right 1, down 3. To the right 4, down 6. So there's your square root shape flipped upside down from the negative. Right, number 11. So this 11 is one of those when we're talking about increasing, decreasing, and constant. Okay, so remember when we worked these problems, the first thing we would do is go through to each part of the graph and label what was occurring in that interval. Okay, this first interval, since it's going down, that's going to be a decrease. The part that's going horizontal, that's your constant. And then the last interval is going up, so that's going to be your increase. Now, so that we don't get confused, the turning points, these 2 points right here, because when you're talking about increasing and decreasing, you're always using the x. So label their x coordinate. What is this one lined up with on the x? -4. This one's lined up with +4. So that's going to help us label our intervals. Okay, so we're going to do increase, decrease, and constant. So the increasing interval is this one. And again, what are the sides going to be? This one's going to be positive infinity, and this one will be negative. So when is this increase from? 4 to positive infinity. Here's my decreasing. So it starts at negative infinity and it decreases until it gets to -4. And then the last is going to be my constant, and it's constant from -4 to +4. All right, 13 is finding the zeros of a quadratic function. Anytime you're finding zeros of a quad function. You can go straight to your quad program. So go to program and then go down to quad. And enter your A, B, and C. And remember who your A, B, and C are. A is in front of x squared, B is in front of x, C is your constant. So 1, negative 10, and 29 gives me 5 plus and minus 2i. Finding the vertex of a parabola. Remember, those x squared graphs always make U's, or that parabola shape. And the point where it changes direction is its vertex. So let's see, it gives me f of x equals negative 2x squared minus 16x minus 35. When we find the vertex, we use the opposite of b over 2a. That's what's going to give us this x coordinate. Once we get the x coordinate from using the opposite of b over 2a, we will replace the x's with that number in order to get the y coordinate. So let's see, the opposite of b will be positive 16 over 2 times a. A is negative 2. So now I have 16 over negative 4, which is negative 4. So negative 4 is the x coordinate of the vertex. So now I'm going to replace these x's with that negative 4. So I'll have negative 2 times negative 4 squared minus 16 times negative 4 minus 35. If I were you, I would just put in my calculator exactly what that says. So negative 2, open parenthesis, negative 4, close, squared, minus 16, open parenthesis, negative 4, close, minus 35. So again, you're just putting in your calculator exactly, oh, what did I do exactly? Hang on. Negative 2, open, negative 4, close, squared, minus 16, open, negative 4, close, minus 35. That looks better. So again, just put it exactly in and then hit enter to get that negative 3. So the vertex is at negative 4, negative 3. 15. So 15 is going to give us a polynomial function and ask for find the zeros and the multiplicity of each of those zeros. Now remember, zeros come from the factors, okay? F of x equals 4 times x plus 9 squared times x minus 9 to the third power. And we're only concerned about the factors that have the x's. This 4 does not have an x, and which means it does not create a 0. So you have these two factors. You can set them equal to 0. Solve them for their x's. So here I would subtract 9. So there's the negative 9 is a 0. And here add the 9s. So positive 9 is also a 0. Now it wants to know the multiplicity. Remember where you get the multiplicity? Those outside exponents right there. So this zero's multiplicity is 2, and this zero's multiplicity is 3. Right, number 16. Graph this function, g of x equals negative x, x plus 4 squared, x minus 1 squared. So the first thing I'm going to do is find its end behavior. Remember the 4 different types of end behavior. They have to do with the leading term. If they are both sides are going up, that is because it is even and positive. Both sides going down, the exponent will still be even, but the term will be negative. If the exponent, if it starts down here, it ends here, that's because the exponent is odd and the term is positive, and vice versa. If it starts up and ends down, the exponent is odd, but the term is negative. So it's not all the way written out, so I don't just see my leading term. I have to envision all of this multiplied out. So let's see. In other words, you can kind of just count your exponents count your x's with their exponents. So that's going to make an x squared. That's going to make another x squared. So now we have x to the 4th. And if I distributed this negative x to that x to the 4th, it's going to give me negative x to the 5th as my leading term. So I need an odd exponent with a negative. So odd and negative gives me this end behavior. So let's see. This graph, the right side is going, the left side's going up, the right side's going down. If that doesn't get you all the way to where you need, then I can also find these x-intercepts. Where is the x-intercepts? This one is going to be at 0. That's going to make a 0 or an x-intercept. It's going to be at negative 4. 1, 2, 3, 4. And this is going to create one at positive 1. So in behavior, and then go to where your x-intercepts are coming from, which are from those factors. Find the vertical asymptotes of the graph. So you have f of x equals x squared plus 3x minus 10 over x squared minus 4x minus 12. Now remember, your vertical asymptotes are zeros of the denominator that are not also zeros of the numerator. And lucky for us, I can use the quad to find all the zeros. Let's find the zeros of the denominator first. So I'll just go to my quad program. My A is 1, my B is -4, and my C is -12. So the zeros of the denominator are 6 and -2. We need to make sure that neither one of these are also a 0 of the numerator. So just go to quad again. This time A is 1, B is 3, and C is -10, which gives me 2 and -5, which means neither one of these are also zeros of the numerator. So those both create vertical asymptotes. Remember, vertical asymptotes are always x equals, not y equals, x equals. So x equals 6 and x equals -2. All right, 18 and 19 are on the composition of functions. That's a f of g stuff. It's giving me two functions, and f of x equals -6x minus 6, and g of x equals -8x squared plus 9x plus 8. And it's asking me to find g of f of 4. So remember, your first step is always whatever is in that position. So I am finding f of 4, which means go to my f function and replace that x with a 4. So I'll have -6 times 4 minus 6. So -6 times 4 gives me -24 minus 6, which gives me -30. Now remember, the second step is you're going to find, in this case, g of whatever your last answer was. So g of -30. Which now means to go to my g function and replace its x's with -30s. So I'll have -8 times -30 squared plus 9 times -30 plus 8. I would just put that in my calculator exactly like I see it. So let's see, -8, open parenthesis, -30, close, squared, plus 9, open parenthesis, -30, close, plus 8. So again, you're just putting it all in your calculator, hitting enter, which gives me -7,462. Number 19. Again, a composition of functions. This time we have f of x equals 4x squared plus 4x plus 7, and g of x equals 4x minus 8. What are we finding? G of f of x. So the first thing, just like last time, I'm going to find what is in that first position. So I'm finding f of x, which it's told to me, right? It tells me right here what f of x equals. It is 4x squared plus 4x plus 7. And that's all I can do with that part. So now you go ahead and go on to step 2, which is finding G of your last answer. So G of 4x squared plus 4x plus 7. Which tells me to go to this G function and replace that x with everything in this parentheses. So I'm going to have that 4. Then instead of x, I've got all this, which is 4x squared plus 4x plus 7 minus 8. So again, instead of 4x minus 8, I've got 4, all that, minus 8. And then distribute here to remove the parentheses. So 4 times 4 gives me 16x squared. Plus 4 times 4 is 16x. Plus 4 times 7 is 28. And then drop down this minus 8, and then you'll notice that those are like terms there at the end. So put those terms together. So I have 16x squared plus 16x. Putting those together gives me plus 20. Number 20. Determine whether the given function is 1-to-1, and it's going to be. If it is 1-to-1, find a formula for the inverse. The function is f of x equals 6x plus 8. Okay, if an x is just an x, it's going to be a straight line, and straight lines they do have inverses. Okay, now remember what the steps to finding the inverse are. What's the other name for f of x? Y. So that's going to change to a y equals 6x plus 8. Once you change that to y, then you're going to invert the x and the y. So that's going to be x equals 6y plus 8. And then solve it for your new y. So you need to subtract the 8 from both sides. So x minus 8 equals 6y. And divide by 6 on both sides. So y equals x minus 8 over 6. And this y, since that's the inverse of this f of x, it's actually going to be f to the negative 1 of x. That's what's saying it's the inverse. (21) Graph this function, and it's an exponential function. F of x equals 2 to the x minus 3. Okay, you could always go to your y equals and put this in your y equals. Now remember, the exponential functions look like this. So it's going to be an exponential function. That's an inside shift. So it's horizontal, but opposite the sign. So it's going to be shifted to the right 3. Okay, if you go to your y equals 2, then go up into your exponent, open parenthesis, x minus 3, close, and then graph it. So you'll see what's happening is it starts to grow over this side, and this side just comes right down next to the x-axis. So if I wanted to get some points, I could go to my table. So what's happening here? So this left side, you'll notice it's going to be down right next to the x-axis. 0 is still barely up at all. 1 is up just a little tad more. To the right 2, up 0.5, which is a half. To the right 3, we're finally up to 1. To the right 4, up 2. And this is where it starts to do that growing. To the right 5, up 1, 2, 3, 4. So there's your exponential shape. Number 22 is going to give us a it's going to give us an exponential equation and ask us to convert it to a logarithmic equation. It tells me 3 squared equals 9. So when you're converting from exponential to log, first thing you're going to have is the log. The base of the exponent is also the base of the log. So you're going to have log with the base 3. And then these two switch sides of the equal sign. So you're going to have log base 3 of 9 equals 2. Log base b of m to the 5th p to the 4th over n to the 7th b to the 9th. And it wants me to express in terms of sums and differences of logs. So they're all going to be this log base b. Everything in the numerator is going to be a sum, so it's going to add. Once we move to the denominator, those are going to be your differences. So we're going to subtract. So let's see, we start off with log base b of m to the 5th plus log base b of p to the 4th minus log base b of n to the 7th, and then minus log base b of b to the 9th. And then we will bring down the exponents. So now we have 5 log base b of m plus 4 log base b of p minus 7 log base b of n. Now remember this last one. If these two things are the same right here, this log is just turning into a 1 because you would have to raise the b to the first power to be b. So this all is turning to 1. So all I'm going to have is this minus the 9 that would be dropping down. All right, the number of books in a small library increases according to the function B equals 6,700 e to the 0.03 t, where t is measured in years. How many books will the library have after 10 years? So I'm going to replace this T, which is representing the years, with a 10. So I'll have 6,700 E to the 0.03 times 10. And then I'll just put that in my calculator. So 6,700, go up into the exponent, 0.03, open, 10, close. And then we're going to round that to the nearest. Oh, I forgot my E. 6,700. E, right? E. Then go up into your exponent. 0.03, open, 10, close. That should do the trick. And round that to the nearest whole number. So 9,044 books after 10 years. Last one, 25. Solving an exponential equation. We have 3 to the 10 minus 2x equals 81. Okay, best case scenario is if I can rewrite this 81 with a base of 3. If not, I'm going to have to log both sides to get the x out of the exponent. So let's see if we can rewrite this 81 as 3 to a certain exponent. 3 to the first power is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. So we are going to be able to use the method where I can just rewrite this side as 3 to the fourth power. Bringing down this side. The reason I did this is because if the bases are the same, then we just need to make the exponents equal. So just set the exponents equal to each other and solve it for x. So subtract the 10 from both sides. So negative 2x equals negative 6. And divide by negative 2. So x equals 3.